Okay, hello everyone, and welcome to the Omniscien presentation on AI and language processing predictions for 2025. I'm joined today by Professor Philip Kuhn, live in Bangkok. He's sitting beside me. We'll also be joined by Dr. Joseph Sweeney. Unfortunately, it's 2 a.m. where Joe is, so he has gratefully prepared a video for us that we will play that'll talk a little bit about one of his key focus areas. It's important to note that there is an extensive series of blog posts that will be published on Monday, over 100 pages of content that is backing all of this up with research. Of course, there's the summaries as well, and today we'll just be going through all the summaries on these key predictions. If you have any questions, please don't hesitate to ask using the chat, and we will be presenting and answering those questions mostly at the end. Also, this video will be available by recording, so if you have to drop off, because it is a 90-minute video today, if you have to drop off, that's fine. You'll be able to pick it up later on. You'll also be able to share it with your friends as needed. Okay, so we're going to get things started. And let's start with first a set of general AI predictions, and then second, we will follow with language industry and language processing specific AI predictions. Okay, so the first prediction is that AI will prove its business value in everyday business. Now, we're past a phase where AI for AI's sake has been happening. It's been constant. We've had a lot of AI just adopted by people, and it hasn't really gone well in many cases. The business has come down and said, hey, let's go and do AI. This sounds cool. All those promises, all these things. They've done it poorly, and in the article blog post, you'll see more details on why projects are extremely high failure rates for AI, more than double traditional failure rates. But what we're seeing now is we're moving away from experimentation to real, solid, best practice-driven execution. Okay, you're going to see a lot more success stories. You're going to see a lot more ROI studies come out. The early challenges have basically been passed. We're starting to see real business value, and we're addressing also persistent challenges overall. So, there's a lot going on, and you're going to see these changes very quickly. A lot of it is about customer experience. And with that customer experience, of course, that comes down to everything from predictive analytics, chatbots, recommendation engines, and overall increasing satisfaction and loyalty. The industry-specific applications, there's a good list here. I won't read them all, but you get the general idea. These slides, of course, will be available later because they are very rich in text, along with all the other information. Okay, so one of the things that's really notable is the revolution in software development. So from things like co-pilots that are connecting to GitHub. I mean, my team here in Bangkok, we use GitHub and we use co-pilots heavily. Just about every piece of new code we're writing has extensive AI backing to it. And I'm still coding even though I'm the CTO. And I'm coding 10 times faster, maybe even more, than I've ever coded before. So it's quite substantial. Also, being able to just say, I know how to do it, but show me, and show me, is this good? Check my code, add error handling, all of these kinds of things. How has somebody else done this complex task? Or analyze my code and find the bugs. These kinds of things are all very straightforward now with AI. We're also getting to the point where its integration with existing methodologies has started to mature. So Agile has really adopted well AI, and we're moving into Agile-based AI development. There's a lot of areas where we're going to see key advancements. We already have. So things like multimodal, which Philip will be talking a little bit on later. Things like human-like reasoning, natural interfaces, and we'll give you some examples of natural interfaces shortly. Federated learning, overall just generative AI, as you've seen. Philip will mention a little bit later on also about explainable AI. And of course, don't forget a very important part of the equation is edge AI, where the processing is actually moving out to the edge. And there's even chips now that are specialized for running AI tasks on your mobile devices, Internet of Things, cell phones, etc. Okay, so the bottom line is that AI is becoming an essential business tool in driving efficiency, growth, and creating opportunities across industries. We're past the experiment phase. So expect to see some of the failure rates drop, but it's still going to be very high as many companies still don't yet have the experience. But that will go hand in hand with success stories. Okay, so I'm going to pass over to Philip now to talk about affordable AI.
Yeah, so I will mainly talk about like the trends, both in terms of technology and business, that cause AI to become more affordable. As we all know, we're dealing here with gigantic models that have really become too big. They're too big to train. They cost tens of millions of dollars to train. They're too big to use. There's really high inference cost and fairly expensive GPU setups you need to run them. And they're also then too big to adapt to use cases. So this is actually a chart from already like almost 2 years ago now, what the size of the models, and you see that kind of max out at around 500 billion parameters. So the good news already is the models didn't actually get bigger than that. So now we also still at most talk about, for instance, the largest Llama model is about 400 billion parameters, and we rather have a trend towards smaller models. So this is already happening. Okay, here just a few more examples about like cost, training cost and the compute involved in training these models. So just very specific examples that we found some numbers for. So Google's Gemini cost $191 million to train, GPT-4, $78 million to train according to some models. Just to kind of give you a comparison, the original transformer model that was originally proposed for machine translation, if you look at that architecture and you would train it on the data we have, it would only cost about $900. Okay, one interesting thing that is happening in this space is that we actually have different clusters emerging in this trade-off of quality and cost. So here we see a chart where on the x-axis you see the price, average price per token going from 1 to 50, and the other one is like some measure of quality, which is the chatbot arena elo. And so there is now already the tendency that multiple models of multiple sizes are being offered at different price points. So what will also drive making AI more affordable is various key drivers. One is more efficient algorithms. There's clearly a lot of interest in coming up with more efficient algorithm, things like quantizations and Elmo and so on. There's also more energy-saving hardware. So we see now also GPUs coming available from AMD, and clearly we hope that maybe over the medium term time horizon there will be more competition in that space, and it will drive costs for GPUs down substantially. There are a lot of compact and efficient models available, even for free. I mean, there's clearly the big efforts from Meta to open source release models. And there's also just kind of the competitive industry pressure of putting AI into edge devices, and therefore really a lot of effort and push towards cost reduction. So we expect dramatic cost reductions over time, and also then that kind of has benefits for kind of all sizes of models you want to use and all sizes of companies who want to use this model for various purposes.
And I'll just chip in here too. One of the things we've been using a lot of the Meta models as well, and not long ago there was Llama 3.1405B. Now that's a huge model. You need huge hardware, and it's very expensive to run. Comparably, Meta's Llama 3.370B. Much smaller model, and it's already delivering higher quality results than the much larger model was delivering.
So there's actually a lot of competitive pressure in this space to drive down costs. So we actually have several companies that build large language models. I mean, there's clearly almost like every month there's a new large language model comes around. And what pressures these possibility of these companies to charge a lot for AI access is also freely available models like Llama. And there are many ongoing efforts from academia, government funding, and nonprofits to build models that are then freely available. Nobody really has a secret sauce. All these models look very, very similar and built very, very similar, built on pretty much all available data people can get their hands on. And so there's no really huge competitive advantage to any of them at the time. On the other side, is also clearly the drive from the user cost to minimize expenses. There is always a trade-off between quality and price. And there's also several ways to balance maybe diminish LLM quality at a cheaper price point with a lot of task-specific adjustments. We're going to talk much more about that later. Okay.
Okay, I'll take this one, Philip. So one of the things that's definitely decreasing costs is the use of tools such as RAG, retrieval augmented generation, and knowledge graphs in combination with language models. Now, one of the things that's getting really noticeable is the quality that even the free models such as Llama 3.3 is producing is adequate for a huge range of tasks. So combining RAG and knowledge graph often can mean you don't need to spend time doing fine-tuning anymore. And it has many other benefits as well, such as keeping data up to date, because you can just update RAG data very quickly rather than having to constantly fine-tune. There's also some great new models on Hugging Face, and they're constantly getting new models, all sorts of things that are really targeted in different areas. One of the interesting ones is Big Science's Bloom, that's really focused on multilingual support across the board with a huge range of languages. And then the last point on this slide is all about easy to access. So you've got pre-trained models, of course, that we've just talked about, but services from companies like AWS with their Bedrock service, where you can just call language models on demand and pay for a few transactions, and they're a fraction of the cost of something like ChatGPT. They really are low cost. We use them heavily. And then you've got various different ways to do strategic resource allocation to make sure those things go smooth, and using renewable energy. Everything's starting to come down across the board. I'll be talking a little bit more later about where things are moving with that and why they're coming down across the board as well. So let's take this to its conclusion. One of the things is really and truly democratization of innovation. These are Lego blocks. They plug in, smaller businesses can join in, they can try things, they can innovate without having to have all the expense of these kinds of models being built, or even the complexity, just call an API in many cases. Of course, that has a much broader impact across every industry in the world. And let's be honest, AI is everywhere now. It's ubiquitous. It's a universal necessity. The things we do, whether we're using Google Maps, it's using AI in the background, whether we're using ChatGPT, or whether we're using a range of other things, all these tools have become ubiquitous. So at this point, it's not a matter of if you want to adopt, it's a matter of how or when, and then how are you going to leverage it. Okay, so moving on to a really interesting one. So foundation model leaders are going to shift their focus to AI applications for growth and sustainability. Now that sounds a little odd, but I'll justify this in a couple of slides' time, and you'll see why. So the frontier labs like OpenAI, Anthropic, they're spending enormous amounts of money on training foundational models. It's extremely competitive, and they have to stay on top of it. You can't just sleep even for a day because the next model comes out. So there needs to be new revenue streams and new sustainable business models overall. We need to, the competition there is massive, and it's intensifying, and there's diminishing returns. The models are getting so good in so many areas. Now let's look at the other side of it. Where is the money really being made today? Well, about 83% of the money in the AI space is at the bottom, at the chips, in the semiconductors and GPUs, right? It's not actually in the actual models themselves. So there's a lot of challenges for frontier model development. As I said, diminishing returns. The costs are excessive. Some of these NVIDIA GPUs are anywhere from $30,000 to $80,000. And you need thousands of them. Like I just read a few days ago that GPT-4 is trained on 100,000 GPUs. That's something like $3 billion worth of hardware. It's significant. So there's some really good reasons why these companies are going to start, and they already have in many ways, moving towards applications on top of their models. Now, let's take a look at where the money's being made. So you can see in the app space, $400 billion, semiconductors, it's down the bottom, right? But in generative AI, it's inverted. $5 billion is being made at the top, right? And at the bottom, it's all about NVIDIA, right? So there's a lot of money being made in the hardware space right now, but that will change, okay? Now, if you break that down to the next frontier, this is how it's going to start moving. So you can see those changes. You can see where the hardware is differing and where the applications, percentage-wise, are making money. So this is what you should expect to see. Look at cloud over the last 10 years. It started with everything driving the cloud was hardware-driven, right? Then the infrastructure on top, like AWS, Azure, right? And today, all of those spaces have grown, but the real money is at the top in the apps. That's where you make the biggest money. And that's the same thing that's going to happen with generative AI. So the hardware is going to become less of a primary component and the applications across the board, no matter what they may be. So, there's higher profit margins, there's greater differentiation. So basically they're going to move up the stack. And this mirrors the trends of mobile phones, for example. It used to be all the money was in the phones. Now look at all the app stores. Apple makes a lot more money, simply out of their app store by charging commissions. Okay, so there's going to be some challenges. There's going to be a lot of competition, and they may even alienate some customers. And there's various kinds of complexities, but it is going to happen. Okay, now this is one of the really interesting ones: agents. So agents will redefine industries by automating workflows, enhancing decision-making, and delivering a hyper-personalized experience across the board. Now, I just had an ad on Instagram 2 days ago. I was in the ad. It modified me to be in a video, right? Now, that's pretty scary and pretty interesting and impressive all at the same time. So we're also going to transition from standard tools to overall orchestrated ecosystems of agents. So let's explore this. What is an agent and what can it do? So an agent can complete tasks all by itself, creating its own prompts and getting the job done. It can generate complete tasks on a goal or based on a goal. And I put a goal down the bottom, for example. It can then figure out if it's done a good job, if it can complete the task, it can read, write, and execute code. In fact, I used some technology today to actually generate some of these slides, including the PowerPoint itself, including the text in it, and then just tweaked it a little and updated it. So what this basically means, though, is it can think for itself, it can reason with itself, act on its own, and then decide if it made a good or a bad decision. So here's a really simple goal that you could give it. Analyze the latest news for data privacy issue relating to public AI services such as ChatGPT and publish it on the Omniscien WordPress website. That's it. It will do every single step for you. It'll work out how to do it and move along.
Hi, my name is Dr. Joe Sweeney. I am the Research Director and Advisor on the Future of Work here at IBRS. Just a bit of background. IBRS is a research and advisory firm. We do a lot of exploration of emerging technologies, and we help all of our clients who are typically the upper middle tier to higher end organizations in their IT planning. Now, something always is amusing to me. I'm really lucky. I get to see what's coming up in the labs. I get to see technology before it hits the marketplace in many instances. But more importantly, I get to see how it lands, how people are actually using the technology. So it's a great role to have. But what amuses me is that we keep on hearing these phrases such as, oh, this new thing has just happened. It's just exploded on the scene. Technology is advancing at a pace that we can't imagine. And we've been hearing that for 30 years. I've been in this game a long time. Now, yes, byte by byte and storage by storage unit, technology is increasing exponentially. But that's not the same thing as saying that the technology is surprising and it just comes onto the marketplace, it explodes, and that it's unpredictable. Absolutely not. The march of technology is very predictable. And this includes AI. People like Dion have been involved in AI for decades. And in many of the ways, the technology is evolving, but it's evolving to a point. This is what we get confused about, technology suddenly being in the marketplace. At some point, we hit an inflection where the cost of using the technology, the cost of processing, whatever that is at a point where it's effectively consumerized. And generative AI is a perfect example of that. Microsoft threw billions of dollars into one of the AI ventures, which enabled it to deploy effectively ChatGPT, amongst others, at a cost that was extremely reasonable. And the cost of creating the AI models and the cost of deploying those AI models continues to decline. That doesn't mean that AI is cheap. Now, this situation tends to lead to overreactions in the market. People get extremely excited. I remember when the iPhone hit the market. It wasn't the first mobile phone. It certainly wasn't the first graphical mobile phone. It was a damn good, changed the mobile phone, but its price point created an entirely new marketplace. And it was really the price of wireless data that drove that innovation more than the device itself. And there's many examples of this all through history. Now, when it comes to AI, we have to realize that over the last 2 years, we have been in the generative AI space equivalent of going back to using a computer without a mouse and with DOS. It's really clunky. This idea that you would have users prompt and interrogate these large language models manually is, quite frankly, ridiculous. And in our projections of AI that we did almost 14 years ago, we expected that something like this would happen. It's happened very aggressively. So what does the future hold? The future, certainly what many of the AI vendors are seeing at the moment, is that their ChatGPT-like, their Copilot-like interfaces are landing well to a few people, but they're not expanding through the business. And the reason for that is really simple. It's extremely hard to demonstrate true financial value when people are having to manually, every single time they want to use the AI, manually work with it. It's a fun experience, but it's not a productive experience. And the result is very clearly, there's a few results. Firstly, job vacancies for AI specialists and prompting specialists have plummeted. So organizations have figured, it's probably not the right thing to do. Another is that Microsoft themselves are not able to leverage those big 300 contracts, trial contracts, proof of concept contracts with their enterprise clients for Copilot. They've not been able to generally roll those out more broadly. And as a result, they are actually experimenting with different licensing options already to try and drive Copilot, the Copilot for 365 utilization. There are many other examples of this. At the same time, ironically, the cost of many of the large language models continues to fall, and we get new entrants almost on a weekly basis. Have to be very, very careful about the true financial machinations of those AI vendors, where they're really getting their cash from. But this is going to continue. It basically leaves us in a situation where a lot of organizations are saying AI is not, it's too hard for us to show the value, certainly with generative AI. The reason behind all of that is, as I said before, we're using these tools to the same extent, the same mindset as basically a computer without a mouse, DOS. It's going to evolve very rapidly. So where are we heading now? 2025 is going to be the year of AI agents. Every man and his dog's going to be suddenly promoting AI agents. And they're going to be talking about non-deterministic computer logic and all this sort of stuff. Sorry, it's not going to cut it. We're going to see, and we are predicting the same situation in 2025, early to mid 2026, where all of these AI agents are underperforming in the marketplace because at their heart, this idea of being non-deterministic means that it's very hard to pinpoint a true business value and productivity gain. There will definitely be some really strong examples, but overall, it's still missing the mark. Now, let's go back 14 years to when IBRS started writing really extensively about AI. We positioned all of these advances in the realm of automation. It's not sexy, but it's right. You see, you can only demonstrate true business value when you automate something, when you remove work or streamline a process or remove a process entirely. And machine learning and generative AI and graph and all of these tools can be applied to processes, to workflows. So we believe that organizations that can orchestrate and understand that they need to orchestrate not just, ChatGPT or some sort of large language, but they orchestrate all of these different AI services, each of which has different strengths and weaknesses, each of which have different security profiles as well. When you can orchestrate that as part of your organization's processes, effectively making AI invisible to the average user. No more manual prompting. Sorry, that should just disappear. When you orchestrate it, suddenly it becomes very, very attractive to businesses. Now, I know the reason why Dion wanted me to speak today is because I've held that position for a while now, and the products which Dion is rolling out are really in that zone. So I just want to say, there is a reason I'm speaking here, but that doesn't take away from the fact that orchestration, that thinking about AI as nothing more than a service. It's not a product, it's a service that fits within some nominated area of your business that can be dramatically automated. Now, there's plenty, when you flip your head around onto that, you suddenly realize that there's many, many areas where AI can be applied very effectively. Yes, you can look at transcription. Yes, you can look at all these other things. But when you think about what else, customer service, how far could you take that level of automation? You take a look at things such as planning, research. Even in our business, it's dramatically transforming our business because we are literally creating very, very complex orchestrations of AIs, multiple of them, that effectively, I wouldn't say eliminate, but dramatically remove a lot of the complexities of doing research. One orchestration that we have takes 47 to 50 minutes to run. It consists of up to 1,800 different AI calls, iteratively working through material, and will eventually just give us an output that says, here's all the information globally known on this particular subject, and here's the answers that you've created. And this is not Google, this is not Perplexity, this is real research. That was a task that used to take us 2 weeks to perform. It's now been shrunk down to an hour or so. But of course, the human's still in the loop on that. We just cut out the grunt work. So this idea of creating these highly effective orchestration chains will be the future. I believe that the major vendors are still very much stuck on this idea of getting return on the investments for their prompting models, their GPT-like services. I think they're going to double down on trying to extend that through agents in the coming year. And it won't be until about 2026, mid-2027, where they'll actually figure out that these just aren't working in the marketplaces, and platforms that allow you to stitch together multiple services, whether they be from, you as one big vendor, say, Microsoft wants to own it all, Amazon wants to own all, or whether they be independent platforms that allow you to bring in the best of breed and open source from wherever you want. I think those platforms will be the future. So I hope this has been informative. If you do have questions, please reach out to me on LinkedIn. I'll be more than happy to engage in conversations and fierce debate on this topic. I know that not everyone agrees with me on this, but I'm old enough and I'm crunchy enough, and I've been seeing these same grand announcements. Oh, this is moving so fast. Oh, this is revolutionary. I've seen them so many times to see the patterns in these. And ultimately, when we do look at it, things like AI are very easy to predict their future from the technology perspective. What's harder is how and when organizations will use them. Thank you very much, and enjoy the rest of this discussion.
Okay, so I'll hand back over to Philip now, but I hope everyone found Joe's perspectives interesting. And I am one of the ones that argues and debates with him, and we've been doing that for more than 20 years with each other. So over to you, Philip.
Yeah, I want to take a bit of a kind of extended view of this concept of agents and where it's heading in the future. So as Joe just mentioned, so we're talking here about the orchestration of what we call agents, which are basically just AI-empowered components that kind of have to collaborate well. And as the word orchestration implies, this is typically done by kind of really arranging them in a certain way that they kind of communicate with each other, they kind of pass jobs through the workflow and so on. But when we talk about agents, we actually also talk about how this process of arranging different components can be done. And it doesn't have to be pre-planned. It could also be automatically generated. So this plan, how these agents interact with each other, might also be done with like basically a fully automatic planning system. So this is like an old concept out of AI, that if you have a complex problem that can be solved in a single step that requires multiple components, that you first have to come up with a plan, and that kind of is a sequence of steps as illustrated here, and then you execute the first step. And then kind of a key idea here is after you execute the first step, you're actually gonna replan. You're gonna rethink how you're gonna execute the next steps, because maybe the first step failed, and therefore your step 2 now is completely obsolete. So you actually have to replan. So this is kind of an old idea of kind of planning, replanning. And this is something we see now happening with language models, where you ask the language model first, what is the sequence of steps should be taken, and then what is the first step, and then you go from there. To give you like some really concrete examples where this is kind of the paradigm that is being pursued. So this is kind of a just started DARPA program, so funded by the US government, where the grand goal is to automatically verifying scientific claims. Of course, these claims are rather complex, and you have to kind of break it down in various components, and all that has to be done automatically. So you have to kind of take the claim, break it down to pieces, and then basically come up, which is called here reasoning chains or reasoning trees, that might involve more than just large language model interactions. They might also involve maybe even running small scale experiments or any other computational aspects to it. So that's what we kind of have to kind of address there in the future. Just to give you one concrete example of such a method is here something developed by colleagues of mine at Johns Hopkins University, where that exact process is brought down. So here the idea is that you have a complex claim here, something about plants and chlorophyll, it doesn't matter what it is, and you break it down to pieces, and you ultimately prove each sub-piece by linking it to a fact that is expressed in natural language. So you imagine, take all of Wikipedia, write down all the elementary facts, and that's kind of your fact base you work with. And any claim has to be broken down by kind of combination of flags, inference rules, and so on, but ultimately at the ground with natural language facts. You can see this kind of concept applies to various other app domains like regulations, laws. That's kind of the fact that ultimately you have to drill down in a kind of legal judgment. And so the task is then, you have to verify the statement, and the solution is that you recursively decompose a statement to substates and ultimately have to prove these against the facts. The interesting thing here is that the facts nowadays might come in all kinds of different ways. So I just talked about text, but it might also be images, it might be audio, it might be databases, it might be charts, diagrams, tables. So ultimately, what a language model draws kind of evidence from to kind of ground this reasoning tree and facts might come down to really complex interactions with all kinds of multimodal knowledge.
All right, let's get to one of my interesting topics. So Philip and I had a fierce debate over this topic. That's probably to say the least. But in the end, I think we came to a general consensus. So based on the information that's been out on the web and comments and many other things, we believe that Meta this year is going to start charging for Llama access. There's many reasons for it. But one of the notable ones is the significant cost. Even though Meta has a lot of money, it still takes a lot to train these. They're on record saying that they use 25,000 GPUs to train Llama 3, and Llama 4 they're using 100,000 GPUs. Now these are 30,000 each. So when you do the math, it's real significant large money. But there's many other reasons. The biggest one is market diversification. Meta is stuck in a world right now that everything revolves around advertising. Having another revenue stream, and don't forget, I talked about these companies also building up into the application space. So having the ability to generate margins just like Apple does in their App Store from meta models makes a lot of sense. So the rising costs, training Llama 3, when you add up all the costs, so the hardware alone, was significant, but when you add up all the human resources, the electricity, getting the data ready and all that, it was about $1 billion. And Llama 4 is estimated, just hardware costs alone at $3 billion. Now, Meta's got a lot of widespread adoption for their models. In December last year, the downloads were going through the roof. 1 million downloads a day of Llama 3.3. It's extensive. So they've had 650 million downloads in total. And the competitive landscape, their competitors are starting to monetize in various ways too. So, we don't expect that they're going to charge everything, at high levels. There's still going to be freemium access and various other things, but there will be different licenses. They already charge organizations like AWS and some of the big companies like KPMG substantial licensing fees. So we expect they're going to have a freemium model for non-commercial and smaller enterprises. They're going to focus on mid to large size enterprises. And this is going to probably have a ripple effect across the industry where people have to reevaluate their strategies and look at it all. But it makes sense. Meta's hybrid approach of different licensing models for a different size business, and at the same time looking at entering applications. And in the blog post, you'll see the kinds of applications that they could potentially go for, and some of the other things that companies are specializing in already. Okay, over to Philip on the rise of People First AI and RAG.
Yes, I'm mainly going to talk about what it actually means to deploy AI at the moment. So yes, there's the foundation model, but then there's all this other stuff that actually makes it practical. So there's retrieval augmented generation. There is knowledge graphs. We already talked about agents, and of course, the foundation models at its basis. So all this put together will outperform kind of building an actual kind of fine-tuning and foundation model. So having a custom AI model in most business scenarios. So you can actually build a lot around the foundation model. You don't actually have to adapt and improve the foundation models, which is a very, very costly endeavor. So this has a lot of benefits. There's efficiency gains. So this Modular AI offers faster deployment, reduced reputational overhead, and cost-efficient scalability. It also makes it much easier to adapt to changing needs on use cases. So it combines real-side insights, structured reasoning, modular orchestration to address dynamic business needs. And this all is kind of a new standard. Business will prefer modular systems for flexibility, scalability, and real-time performance over resource-intensive custom models. So why is it that modular AI outperforms custom models? So one is cost efficiency. So the custom models require significant financial and technical resources. So this basically means you have to take a very, very large model. And even more so when you use the model, when you train the model, you need even more computational resources. And you basically have to do a massive training around it. So this is a very, very expensive thing to do. So therefore, it's better to kind of have kind of general models that then you build modular systems around. So this is then, things like RAG as a method, knowledge graph as a method. So these are all kind of then provide information to the model on demand. So when you kind of interact with the model, that information comes from outside sources and gets combined with a foundation model to kind of draw conclusions. So that has all kinds of kind of real-time relevance. So you can actually update the models much more quickly. You can add more things in your database immediately. So your RAG can dynamically retrieve real-time data for up-to-date outputs, something that couldn't be in kind of the base foundation model, because these get rarely updated. Also, the knowledge graph allows you to kind of have more structural and contextualized information for deeper reasoning. And all this makes it also easy to deploy because you have, the pre-trained models on one component, API calls to this or other kind of logic units in the back. And then you can integrate that in various ways in workflows, and you can much quicker experiment with that. And also this enables much more interpretability. So the key components for kind of really building AI systems today is basically combine these components. So there's retrieval augmented generation, where you kind of retrieve relevant information on the fly and kind of combine it with the abilities of the language model to reason over it. Knowledge graphs, you already mentioned, AI agents and foundation models. So we believe that the implication for that for industry is that modular AI will dominate most use cases, reducing dependency on custom solutions, and custom models will remain relevant for specialized, highly regulated tasks. So if you have a lot of training data for a particular task, actually machine translation is one of them, we'll talk about that more later, it actually does make sense to kind of build a custom model, because the amount of training data you have for a particular task, this is still relevant. But for most practical use cases, having this kind of more modular approach with various components will be much more beneficial. Let me also kind of go a little bit more into like how these models are being used and what actually AI today means. So when we actually look around here, what are really the use cases people talking about? So we already talked about coding, and apparently Guillaume got 10 times faster coder. I have similar stories. I can't put a number on it, but yeah, it's definitely much more productive. And I hear a lot from people as writing assistants, and Leon also already mentioned that you can make PowerPoint slides now with ChatGPT. So these are kind of the use cases that are really compelling that people talk about a lot. And these are kind of the good use cases. They're also kind of the misuse of this technology. So it's kind of popular now for apparently students to cheat in the homework by just asking ChatGPT to do the homework for them and pass it off as their own. And there's like this famous case from, I think, about a year ago, where a New York lawyer kind of created a legal brief with ChatGPT. So yes, so this is kind of an interactive scenario where you as a human work on a task, and the large language model or the AI helps you do the task, but ultimately you're still responsible for basically executing the task. So in contrast to that, if you use large language models as fully automatic systems, that bears a lot of risks. So every AI system has an error rate, and what is the acceptable error rate? That depends heavily on the task. So we've worked on machine translation for now a better part of 2 or 3 decades, and we always had the mantra of it has to be good enough for purpose, and the good enough for purpose might differ if you kind of use machine translation when you travel around for tourism versus translating a legal brief. And here, for instance, the example self-driving car, there the bar is really, really high. A self-driving car that 99.9% of the time doesn't crash is not good enough. There's some famous cases where you get fully automated systems, like here chatbot, where Air Canada made up refunds, and basically the airline ultimately had to honor it. So we see much more advantages to using large language models as interactive tools for humans, where the user vets the responses and only uses what's correct, and then may also iterate over prompts and responses to get desired results. So another reason this is now kind of ties with this idea of RAG and kind of evidence-based kind of reasoning, that a user ultimately has to validate if what he gets back from the AI is trustworthy. And if you can link it to actual evidence, that's kind of a very key feature of kind of trustworthy, kind of in ensuring trust. Because if whatever statements are generated by the language models are backed up by actual, human authored documents with known sources, then based on your trust in the sources, you can then trust the statements and believe in the output much better.
All right, this is a rather tricky and sticky one. Regulatory, security, and compliance issues. So the key drivers, there's definitely a lot more stricter regulations. So GDPR, the EU AI Act, and various other data sovereignty laws. That's driving a lot of things. And, it's forcing a lot of people to be a lot more careful. But it's moving systems in the right direction, where it's going to drive AI strategies in the right direction for the right processes, keeping it secure. Now, we've noticed when we're dealing with our customers, we're having to deal a lot more with InfoSec departments, explain to them what we do, how data is used. If we're using Bedrock for a customer, then why don't we have it on-prem, and we explain the costs, and they can still choose to have it on-prem or they can use Bedrock. So they've got those choices. There's critical shifts now happening from reactive compliance when they get caught doing something or something silly happens to proactive governance. The business is now prioritizing transparency, risk mitigation, and overall consumer trust. If they get caught breaching these violations, the reputational damage alone, let alone the other monetarily punishments, are pretty shocking. Compliance and security are basically no longer optional, but foundational for long-term success in any of these regulated spaces. You must comply or you can't play. Now, the risk of non-compliance, well, let's look at a few. Meta was fined 1.2 billion not long ago, Uber 290 million, and LinkedIn 310 million. It really hurts. These are real monetary penalties that are significant. They can do reputational damage, operational damage, and even somebody as big as Meta doesn't want to blow 1.2 billion on nothing. Overall, they're looking at different organizational deployments, more secure private cloud or on-premise solutions to keep better control. Because every day in the media, you see that someone else has been breached, somebody's data has been lost, and hundreds of thousands of people's data is being lost on a daily basis. So there's strategic solutions, there's more advanced cybersecurity, localized infrastructures that I mentioned, federated learning, region-specific data centers. For example, Amazon, they now have in a number of countries, Amazon GovNet. So these are government-only systems that run aside from the main AWS, the data privacy disconnected from the main AWS. Okay, and that leads into the next point, self-hosted AI. So on-premises and private cloud, there's going to be a resurgence for the exact reasons that I just talked about. So, in 2005, sorry, there's a typo there, self-hosted AI will start to reshape enterprise strategies. A lot of countries are really hammering, compliance, on-prem, data sovereignty in particular. It's driven by control, customization, and compliance needs overall. And the regulatory demands are huge. Now, our platform Language Studio runs entirely on-prem or in private cloud, and it can even be air-gapped from the entire internet. So that's one of our strategic advantages over all of our competitors. but many people are just using regular cloud-based AI. So something as simple as Google Translate. Right now, if you copy and paste a company's contract into Google Translate, you're actually in breach of many of these regulations straight away. And these things are going to start to get more strict. Also, there's hybrid models where you can combine on-prem and cloud integration, or on-prem and AI on demand, which is something like Bedrock, which ensures data privacy all the way through. These also allow for prototyping and especially scaling. So as you grow, rather than buying hardware, doing self-hosted but private cloud or AI on demand can be a lot better. Okay, so I mentioned the different deployment models there: on premises, private cloud, and hybrid. The big leading applications in this are healthcare, finance, and government, but regular businesses are doing it all the time as well. And there's a lot of advantages. Obviously, your compliance, it gives you control of your data and tailored customization, and scalability and flexibility. So it is well worth looking at these options. If you need the data privacy, you want to access all of your data without having to worry about who's got it secure, who's holding the keys, who's hacked their system, then self-hosted in private cloud or on-premise is a pretty good option. Okay, let's move on to the other half of the presentation now, the language processing predictions. Okay, so this is an interesting one. It's something we get asked all the time. When will computers beat humans? Well, it's happening in some areas. And let's be very, very clear here. There are multiple use cases we've seen where AI can match or outperform humans, and it's increasing. The humans are still superior in many areas, but AI is catching up. And there's many areas that AI has an edge. So for example, speed. Okay, a human translates at 3,000 words a day. Just a single machine can do that in a couple of seconds. And bigger machines can do billions of words a day. Scalability on repetitive tasks, large-scale tasks. Accuracy, yes, I said accuracy. When things are done properly, you do the right terminology work, and AI helps there too. I'm not just talking about translation here, by the way. I'm talking about the entire localization stack, everything from transcription to onboarding data to project management, translation certainly there, quality control, terminology analysis and extraction and definition, creating style guide using AI. These are all human steps, right? But AI is stepping into these places already, and it will fully automate many of them over time. Not all of them. There'll still be many areas for humans. And in fact, it will actually increase human activity in many areas. Automated quality assurance, right now, if you do QA, in many cases, unless you have a huge budget, you're doing spot QA checks. Automated QA can do QA on every single sentence. That's something that humans perhaps cannot do in a time frame or just because of a cost basis. So there's operational cost reasons to do it. It's getting better enhanced reasoning and domain expertise and improved interfaces and integrations. So where is it superior now? Well, bulk content handling, e-commerce catalogs, customer reviews, hotel reviews, those kinds of things. Real-time updates, games, domain-specific tasks. Actually, specifically law, medicine, and tech are really doing well because of its ability to handle terminology so well. But the terminology work has to be done. Now, that's where you come to the next one. It's also a negative terminology. Consistency across projects, managing multilingual projects on large-scale data sets can be challenging. Also, the data sets it's learning from are often inconsistent. So some of our new tools with our automation tools will give you an opportunity to normalize terminology. So, we might talk cloud computing today, but a few years ago, they might have called something very similar client server or a variation of client server. So the terminology and vocabulary is evolving. The advantages over human workflow, of course, speed, cost efficiency, and error reduction. Is it a magic wand that solves everything? Of course not. But the point is that there are more and more use cases where machine or machine plus human can easily exceed human only. The last points, it's all about collaboration. It's not about just this machine running off and doing all the work. It is very much about collaboration. And there'll be new roles for humans. There'll be roles that humans can still excel in for a long time to come, but we'll talk about one of them a little bit later, creativity and emotional depth in literature, marketing, and poetry, things like that. Handling ambiguity. The AI is getting better, but it still needs time to mature. So the best approach going forward is a collaborative approach with post-editing to get polished results, leveraging AI to expand reach, and while maintaining quality and scalability without having to sacrifice cultural and contextual relevance. Okay, I'm going to hand back to Philip.
Yeah, now we're going to talk about like how AI changed machine translation. Although it's a bit of a weird way to talk about it, because if you really look at AI today, you talk about the transformer model, which is a machine translation model. So just to be for clarity, when I say now machine translation, I talk about a dedicated machine translation system that was built to do translation. When I talk about AI, I mainly mean large language models or related technologies that take a much broader view at language or even other modalities of data. So we believe that AI assisted translation, so where we not just use a dedicated machine translation component, but we also build kind of a very complex environment of AI around it, will become an industry standard in 2025. And AI will extend beyond just the kind of machine translation part of this, but the entire workflow of localization. So that allows humans, translators, to focus on creative, culturally, and kind of more sensitive, nuanced tasks. Just to kind of give you a bit of a picture of how this looks like. So this is kind of a typical translation workflow where you have a document to translate, you send it to machine translation, you have the MT output, and then the human post editor and human quality control, and then delivery. So this is kind of where we have been maybe already for kind of maybe a better half of a decade. So you get a lot of productivity gains out of MT because you only have to fix the mistakes, which is much faster than writing it from scratch. So let's just say here, if you work on MT, you're going to be 50% faster. So now what we're going to talk about is an additional component of automated AI post-editing. So this is something we currently spend a lot of investment on, how to get that right and how to kind of combine the raw MT output with very dedicated automatic revision components, where now the AI that's doing revision. Okay. The next step would be then also to put in automatic quality control. So here you basically have the ability to say, okay, at this point, we're pretty sure the translation is good enough already, and there's nothing wrong with it. So no human post-editor even has to look at it. So that kind of cuts on even the need of a human post-editor to look at the translation. And so this goes all the way back to kind of the human quality control. So after the human post-editor, there's typically a human revision stage, and even we might be able to skip that step as well. So that doesn't have to be done either. Okay, so by basically having evidence of things being right and having feedback from human quality control, this is actually a component that can improve over time and kind of bypass human through the entire process. So this is kind of a rough outline where like two parts where like we expect AI to make major contributions, but it's really the entire chain of localization. I'm not going to go through the list here, but if you just think about like from the beginning, from initial consultation and the kind of preparing research and delivery and feedback from client, all these components kind of just ask for having improved kind of processes aided by AI. Since we're talking about AI and machine translation and kind of made this distinction between like the core MT component and the AI around it, we're still kind of struggling a bit with that. The core MT component can be very efficient, can be very fast, can be very cheap, and can be very deployable and adaptable, while the AI component is really, really expensive because this now involves these gigantic models and all the interactions for this. But there's now increasingly interest to maybe can we just fold that all into the dedicated MT engine, so we can still have a nimble, fast engine that does all these complicated things that we just talked about, or also illustrated here at the slide here, you know, what you can do with large language models. You can specify style, you can provide terminology, you can add all kinds of constraints. These are all things you can do with large language models. And ideally, we want to do this inside the machine translation model as well. So just to kind of point to like ongoing research, so this is work at Microsoft, where they basically worked on kind of instruction fine-tuning machine translation models. So we basically take a machine translation model, and now we also allow it to be fine-tuned with instructions. So you not only say, here's a source sentence, but you provide the source sentence and additional instructions to then kind of guide the process of translation. So this is really interesting work. So here's a bit of the cartoon illustration of this. So we typically have the trade-off between, in the lower left corner, the MT, which is not as capable in terms of kind of the style adaptation or terminology coherence and so on, but it's fairly cheap. And on the top right, you have the large language model, which is very expensive, but has all these capabilities. And we basically want to look into how can we extend the MT models to have all these capabilities while still being nimble and cheap to be used. It has still a very small memory footprint and compute cost. Going now to the flip side, which is large language models. How can we make them be better at translation? So it's actually interesting. For several years, people just kind of looked at how good can ChatGPT do machine translation, although ChatGPT was not specifically optimized for machine translation. Clearly, I've seen a lot of translated data, so that's why it could do the task at all. But really, if you want to use a large language model for machine translation, we should actually train it to the task. So clearly, large language models are instruction tuned for various tasks. And one of these tasks probably should be machine translation. And it's relatively straightforward to do this. You basically take all the parallel data you have and convert it into chat format. So here's like a typical kind of instruction prompt there. Translate the following sentence from German to English. In German, das Haus ist groß. In English, the house is big. And that's kind of the instruction data that you fine-tune your model on. I just want to highlight two particular kind of instances of work where this has been recently done. So this is work by Alma. A project called Alma is work done at Microsoft and also with students at Johns Hopkins being involved, where the important insights was that it's actually fairly important to pull this off by adapting a model like Llama to machine translation that you also pre-train on a lot of monolingual text, so it's just much more aware of the text, and then you might not even need a lot of parallel data. So in this paper, they really made the point that you need relatively little high-quality parallel text to get really good translation performance that kind of beat GPT 3.5. Here's another effort along those lines, which is from Babel, who put a lot of effort also to adapt language Llama 2 with large amounts of monolingual data and parallel data, with various filtering with a kind of Comet Kiwi kind of filtering technology, and also instruction tuned data from other tasks, and also multi-shot translation. And interestingly, that both the training data and some of the models are publicly released, and you can use this. So this is probably, at this point, the most serious effort actually to adapt a language model to machine translation. But it's actually interesting that the computational cost for that is actually not that massive. So we do expect this to happen more and more. Oh, here, the last thing I want to say about like this whole debate, MT versus AI. So these are results from, it's like 2 months ago, from the WMT competition, where basically a blind test set is presented to various online MT systems and large language models. But the main purpose actually of this is to kind of for research teams to compete and try out new things. But at the end of the day, we're going to have a ranking where we basically see which performs better on a previously unseen test set that no other system has access to. And well, on the one hand, the good news is that the humans still win most of the time. And otherwise,
most of the time.
Most of the time. And the reason why they don't always win is like, yes, if you hire translators to do a translation job, they might do work that is good enough for their purposes, but not the best they could possibly do. Otherwise, it's I mean, if you look at the blue boxes, these are all the dedicated MT systems, and the green boxes, which are large language models. It's kind of a pretty open competition right now. It's not very clear what is really the best thing to do, and it really heavily depends on the language pair. Okay, just finally an outlook. of kind of this debate of AI and MT. So the key impacts of AI integration and translation is, yes, it allows you to kind of automate repetitive and data-driven tasks with efficiency. It enhances quality assurance, even for lower budget projects. It supports every translation stage, as I kind of pointed out, preparation, translation, editing, and so on and so on. And there's a lot of benefits and future implications. So it kind of makes everything cheaper, makes everything go better, improves global communication through efficient, accurate translations, ensures cultural relevance and nuanced understanding with AI-human synergy, and redefines the translator roles as editors, mediators, and project managers.
Okay, now we're going to get into an interesting part. And in this part, I'm just going to jump over to something on the other side, and I'd like to introduce you to a little friend of mine. His name is Humphrey. Hello, good morning, Humphrey.
Good morning. How are you today?
I'm really good. Today I'd like you to do some research for me. Can you find some information about a company called General Electric and their heavy engineering machinery, in particular in the area of power plants?
Let me have a ponder on that for you. General Electric, or GE, is a big name in heavy engineering machinery for power plants, especially with their gas turbines and combined cycle power generation. They're known for their HA technology, which is super efficient, and their 9H.02 gas turbine is a highlight, being designed for high efficiency and reliability. They also use additive manufacturing to boost efficiency and have advanced control systems to improve reliability and reduce costs. Anything else you'd like to know about them?
No, that's perfect. You've found the right area. So now I'd like you to do some role play with me. When I say ring, ring, you're going to answer the phone as if you're an internal support agent, and I'm going to be one of the field engineers within General Electric. Ring, ring.
Hello, internal support at GE. How can I assist you today?
Yes, I'm out in the field and I'm beside a dam site 453, and I've noticed that one of the plant sheds has been broken into and been vandalized. I've gone inside and had a quick look, and I can see that there's broken equipment. Some of the covers and some of the glass on the front of some of the big equipment has been smashed, and I'm worried some of the insides are also damaged.
Oh dear, that sounds serious. First, make sure the area is safe for you to be in. Have you been able to secure the site and report this to local authorities or your supervisor for immediate action?
I haven't reported to anyone yet. You're my first call, but I did make sure nobody was here. What I found is there's a hammer, and it looks like that's been used to break one of the glass panels, and there's also quite a bit of graffiti here, so it's probably been kids, and I'm not sure when it was. It could have been some time ago.
All right, thanks for letting me know. It's important to report this to your supervisor and the local authorities as soon as possible. They can assess the damage and ensure everything's secure. Do you need any help with contacting them?
Yeah, I will contact them directly. I will do that just after this call. But can you make sure this is logged in the report system so that there's a record of when it happened?
Absolutely. I'll log this incident in our report system right away. Make sure you take some photos if you haven't already, just in case they're needed later. Is there anything else you need help with?
Yes, can you do a brief summary of everything we've talked about so far, please?
Certainly. You called from dam site 453 where you found a plant shed broken into and vandalized. There's broken equipment, smashed glass panels, and graffiti. A hammer was found, suggesting it might have been used in the vandalism. You're planning to report this to your supervisor and local authorities. I'll log this incident in our report system for record keeping. Anything else you'd like to add?
Yeah, email that to me, please.
I'll get that email to you right away.
Great, thank you very much. Bye for now.
You're welcome. Take care and bye for now.
Let's go and look at how these are used. So conversational AI is really kicking off. We've got a range of offerings in that already, and we're working with partners to do a whole range of other features. It's pretty amazing when you get these things going. And I'll tell you how good they are. We did a fake customer support call where we asked the tool to imitate an agent for their company and research them online. And that's what I was going to do just then for Morgan Stanley. And it's all live and in real time. It then went up to their management. We did a recording, and they thought the recording was real and somebody had hacked their system and got access to internal data. That's how realistic it was. And they were very concerned, but then they were pleasantly relieved when they worked out that the machine got everything it needed to do to act as a customer support agent directly off the internet and just their reference data. So real-time translation and conversational AI are going to be omnipresent by the end of the year. It's just built into so many things. Seamless communications across languages, integration into smartphone, glasses, telephones, or computers like I'm running now. It's going to have a massive impact when the user interface changes from text and typing to talking, and talking to almost anything, right? Talk on the telephone. Now, you might have noticed that ChatGPT's just launched a new service. You can call 1-800-CHAT-GPT and just talk to them on the phone, and it gives you an answer, just like I was doing then. Okay, that's simple. So, you might not have access to the web every time. Customer assistance. We had a proposal out to one of our customers where it was a large government department equivalent to the FBI. They had to do 20,000 interviews, preliminary interviews for a legal case. And we put forward using these tools. And we're going down that path for future projects. We didn't have enough time in their timeline. But actually having the AI have live interviews with victims, 20,000 victims, that just wouldn't have been possible. They were only going to interview 100 of them. And this made it possible to do 20,000, which they're planning to do in the same scenarios should they come up again. So key industries are government, of course, healthcare, customer service, all these kinds of things. But it's not just multilingual assistance. It can really hook into everything from your custom agents that go out and do the things like Philip talked about earlier. I can just ask it to go and book me a haircut appointment, or book a restaurant for a visiting guest that I have tonight, or change my flight details. All these kinds of things, or look up things in the middle of a meeting, say, hey, my colleague said something 10 minutes ago about the price of these widgets. What did he say? Remind me, I've forgotten. Oh, and now at the end of the meeting, please tell me a summary of the key things that were talked about and drop them in an email to me. All of these things are immediately possible today, and we're shipping these products right now. Expect to see a lot of competition in this space, but it's an amazing space to play in. They're going to be on consumer devices. They're going to be inside Teams, where in something like this, I could just recall. Live captions, note generation, and not just basic notes. The stuff that Teams does is very, very simple and basic. If you saw our webinar a couple of months ago with our business AI tools, you can see really comprehensive notes, breakdowns, even fact checking. So I went to a conference in Dubai, and Boris Johnson was on stage, and I was in the back of the room. I just recorded his presentation on my phone with 800 people around me. I got back to the office. I said, right, analyze this, write it up. And it went through and it did X, Y, and Z and give me some great summaries, quotes on different topics. But at the end, it says, here's 2 facts that he claimed that are lies, and here's why they're lies, right in the middle of the document. So all of these kinds of things are possible. Public service announcements, all these kinds of things. And it's multimodal, audio, text, and visual inputs all together, hands-free while you're driving, right? These kinds of things. All of this is possible. Okay. So it's fluid, it's natural. I'll post a couple of recorded examples of it on the website afterwards so that you can play them and see what's really possible. It really is truly amazing. And now we're tying that into things on the back end so that, it can do customer support, it can look things up, it could register your product or register a complaint, all of these kinds of things.
Yeah, I just want to give you a quick kind of glance at what is involved in kind of this technology by combining kind of previously textual translation with machine translation, with speech recognition. So we basically have this task of someone directly speaking, and we basically want to translate it into another language. And it typically requires the steps of speech recognition, converting the speech into text, then text translation, so the machine translation, and speech synthesis. So there's a lot of work on this. This is kind of a most exciting topic of generally also building multimodal foundational models. So this is kind of a really interesting space we're currently working in. So the kind of really big goal in a lot of these efforts is to kind of convert this step-by-step process, also called a cascaded approach, to an end-to-end process. However, let me just skip that. So this also enables, for instance, that if you do this process live, you don't have to kind of go through all these steps, and you can do much, much faster kind of simultaneous translation. So you don't have to kind of first wait for the speech recognition to kick in, and then for the text translation to kick in, and then for the synthesis to kick in. That all adds to the delay. So if you have to have an end-to-end system, you can do this much more quickly. So this does involve kind of algorithms that figure out how much do you have to wait for input signal to come in before you produce output signals. So there's, like, for instance, these kind of wait K policies that are being used. There's fundamentally the challenge that for all these kind of separate steps, we have either moderate or a lot of training data, but for the end-to-end process, we have very little data. So there's various things that can be done about it. So one of the solutions is to kind of synthesize the pieces of the data that you don't have. So if you only have a lot of translated text, you can synthesize the audio on the source or the target side. Or the other big solution is to kind of build these models incrementally. First start with a text translation model, and then just add audio input modalities at the beginning, and then a synthesis at the end, and then kind of only at the end with the kind of the precious end-to-end data, fine-tune it on the task. The other thing I want to talk about is also that where we don't have to stop at speech, we can also kind of go all the way to video. Because communication is not just the literal meaning of that can be reduced to text. There's a lot of emotional and nuance in the speech and the physical expression. So basically, we want to build models that also draw on video recordings, on the facial expressions, on mouse movements. Just to kind of illustrate this here, so you can imagine that in the input video, you get a lot of insight from the facial expression, how something is actually intended. And you can actually then take that into account when you do the translation, which also, if you want to generate the video at the end, you also have a lot of challenges to basically map the output image to exactly the correct emotional kind of facial expression and gestures in the output video. So these are kind of all really, really interesting and challenging problems. Here's, for instance, one example of how this works. Basically, you kind of start with a text-to-text translation model, and then you kind of add all this additional modality information on the source and target, kind of bring all these different means of communication by vision, by speech, by text on the same kind of representation space to basically then build kind of an end-to-end system that can take both text, video, and audio as input.
Okay. And the last topic today, I think, not 100% sure, we'll find out in a moment, is about widespread use of AI for creative translation and localization. So, I can't think how long it's been, but for years, decades, people have said, oh, I'm creative. A machine can never do what I do. And I've heard that for decades. Okay, well, the reality is that machines are becoming creative. And in some cases, they're even more creative than humans. I've been absolutely amazed at some of the graphics, some of the way things have helped me in my writing and things like that, and so on. But combining, a range of things. Now, it's usually a collaborative creation where it's a iterative, here's an image, yeah, but I don't like that, fine-tune that, add a seagull in the top corner, take out this, tone the brightness down on this part of the image, or add shadows, and off it goes. But it's doing creative tasks. It's doing that in text mode as well, and it's doing it in a range of other things. When you hear some of the conversational AI, you'll just see how creative the voices get, where they're showing expression, they're showing all sorts of things, and it becomes very hard to work out what's real and what's not. So it's combining the accuracy there. So, it's going to change literature and even translation. It can be really creative. So let's look at some of the drivers. Obviously, transcreation, taking in intent and tone, cultural adaptation, understanding things there. Specialized AI models are helping that a lot, but even regular LLMs can do a lot of it with the right guidance. Human AI collaboration is the key behind the whole thing. It's storytelling with a balance of efficiency and artistry together. But let's have a look at some. So on the left here is Spanish, and this is using our tape tools. That's the original Spanish. And here's raw machine translation. Okay, now it's a perfectly good translation all the way down. There's nothing wrong with it at all, except it's boring, even though it's a perfect translation. Now, the use case in this case was to make it for a telenovela being translated from Spanish into English, and they wanted it in synopsis form so that you could put it up and compel people by reading the synopsis to watch the episode. So if I go here and say, you know, Fabio argues with his wife Carla and she leaves the house. Doesn't this sound better? Fabio gets into an argument with his wife Carla and she walks out on him. In the morning, he has to take the children to school. In the morning, he's left to take the kids to school on his own. But this one's a real killer. Later, Carla comes home and asks him for a divorce. Later, Carla returns and drops a bombshell. She wants a divorce. She's out of there. Right? So it's that kind of creativity, and that's guided. Now, it's also able to change a lot of other content to be richer. So here you can see Nacho takes the DNA test with the help from Emma, his secretary, and it's the same on both sides. But when they want to do it to Yoni, which is exactly what's written in Spanish, they discover he ran away. But the translation that's been fine-tuned, when they want to administer the test to Yoni, it sounds so much better, right? So it's stylizing and making it suitable for purpose. And these are tools that we're getting a lot of fantastic feedback from. Okay. We can optimize to different writing styles. We used to do this by training different MT engines. We don't do that anymore. We can just tune the outputs. And Philip mentioned having this actually built into the engine itself now, where LLM functionality and guidance is being built into the back end of the translation process directly in the NMT engines. Now, this is where you might be really surprised. So this is very thick, strong, nasty Australian surfer vernacular. And I'm from down under, I'm from New Zealand, and I can't understand this. But it's really hard, you know. You had a proper surf, you know, you get the sand all up your clacker and down your gobbler, you know, all of these kinds of things. No idea what they're talking about. So our AI tools did analysis. Two friends, likely male. Okay, you can see sharing a casual conversation. What's the scenery? What's the situation? Then what's the tone? So it's pulling all of this out of just a handful of sentences. Key elements that it can find. So because of the vocabulary that was used, they've decided it's Australia, UK, or New Zealand. And that's accurate. It's full of colloquialisms. Now, what do these words mean? So cheers, mate. Okay, simple enough. A quickie. A quickie in this context is a brief snack or a drink or a meal. A proper surf is a great or excellent surf. Clacker is your mouth. Okay, gobbler is your Adam's apple. Beef cap is slang for skull. And anteater is your nose. Okay, so now that you've got definitions, you can translate that. And you can choose the right slang or whatever. And you can even have the AI suggest the right terminology in the target language. Okay, so transcreation with these kinds of things, with idioms, with metaphors, emotional resonance, are all there. Marketing campaigns that are tailored to local cultural context can be done today. Okay, you can upload an existing marketing campaign and say, use the same style, mirror this kind of context. Okay, it deals with cultural missteps, even poetry. Okay. Context-aware, multimodal from text, audio, and visual all the way through. Okay, now it should be collaborative because it doesn't know everything, but it's really helpful. And then workflow optimizations and hyper-personalized marketing. Like I mentioned earlier, I was on Instagram and a video ad came up with me in the video, right, directly. So all of these things are there. And I knew there was one more. Okay, the rise of no human in the loop translation. No human anywhere. Well, maybe a little bit. Let's see. Okay, so we have no human in the loop. What does that mean? That means seamlessly operating without human intervention. Okay, fast, accurate, cost-effective machine translation in some tasks that we're doing now is surpassing human levels. Okay, so we're currently doing a project I'll talk about in a moment that many of the translations to English are beating what a human translator would do because it's taking in that creativity process. It's a lot slower to translate than standard machine translation, but a lot faster than humans, but it's absorbing them and bringing them in. And then it's analyzing, it's from Germany and it's this context and it's soaps and dramatic, and it's applying that into the translation directly. So it's taking, first of all, it's doing speech recognition, then it's doing translation, and then it's doing subtitles. And I'll show you a little bit more about that in a moment. There's going to be big impact on business with this, both real time and batch mode. It reduces the reliance on humans, which in many cases can be a good thing. If you need an instant transcription, you don't want to be waiting for a human. Okay, so this is one of our customers, UFA in Germany. They're processing about 20 or 30,000 hours of content. Okay, so it's a world first. We launched it with them just a few months ago. It's taking German content that's about 20 to 30 years old up till just about 8 years ago, something like that, maybe 5 years ago. It transcribes it with a custom transcription model that we've fine-tuned. We then do speech automated post-editing that fixes bad speech recognition and fine-tunes the structure, because speech recognition doesn't always give you the best sentence boundaries, things like that. Then it does a quality control pass. Now, some of the content is bad. It's just really old and the audio quality is bad. So it gets flagged and a human can come in and check it. If it passes automatically, it goes down to translate. And then it translates, and we use translation automated post-editing, like I showed you with the synopsis, that fine-tunes it for soaps, sensationalizes it, makes it dramatic and emotional, and all these kinds of things. Then it goes to quality assurance again, and if it passes there, then it goes directly to YouTube. No human in the loop, thousands of videos. Okay, that's substantial. Now, what this is about is good enough. Good enough translation. Now, is it perfect? No. It picks up the music and transcribes their theme song. It picks up a television in the background sometimes and transcribes that. But compared to paying $1,000 versus less than $100 per episode, right? These are the differences. It makes these use cases viable. It makes it possible to monetize them and drive things forward. So, many use cases you can have no human in the loop because it's good enough. You can accept a non-perfect but pretty high quality result, right, as a trade-off for mass volume and low cost. Okay, so there's many monetization opportunities that can unlock audiences, films, and media, revitalizes old content, real-time content translation, translation quality improvements, and all sorts of ways to give new ways to get market access to foreign markets. Okay, and that's the last one. So if you have any questions, please feel free to jump on. We're almost at the end of our time, but we'll go a little bit over to answer some of the questions. And I'm just going to roll up the questions now and see what we've got already. So Philip, how about this one? What do you think of this? Okay. How is text recognition coming along? We have a large set of data confined to PDFs, and it would do wonders if these could be accessed for predictive purposes.
There's clearly a lot of work on that. So this is kind of OCR, and PDF are historically nasty. So this is something where actually kind of these AI vision models, text models have made significant progress. So just to give you an anecdote, what I tried recently is basically coming out from scientific papers, wanted to extract the tables, and then they're basically just images. And how do you get the text out and convert them to kind of readable format? And I just kind of tried out ChatGPT for that. And it actually worked really, really well. So basically by combining kind of text models, image models in one big kind of component, which then not only can draw on what it can just like identify from the characters on the screen, from the pixels, but having like the broader context, what it could possibly mean, what is it kind of the broader context for that, you can actually do much better. Clearly, PDF has a lot of challenges, including what that formatting is on the PDF file, and how much you want to preserve of that, and how much you just want to have the raw text out. So yeah, that's kind of it's actually really amazing how much PDF is.
Right.
I mean, it's a really hard problem.
It's a really difficult problem, and a couple of years ago, Philip and I and a few others were working on a big project called Europat, and that had hundreds of thousands of patents that were all in PDF format in many cases that we had to get data out of and restructure. But if we had the tools today, I think it would be a lot easier. Okay. Next question. How many languages does AI voice response include, and what are the plans to have all languages, and how about picking up slang and so on? Can it keep up? Okay, so today it supports 55 languages, and it can speak in about 140. Okay, so if you add translation in there, it's pretty good. With respect to slang, it's been trained on slang and a lot of other information as well. So it can keep up on that, but you can add glossaries and other things to capture the slang and capture unusual words. So, for example, we're working with one of our media companies that we work with right now, where we've written a tool that is doing Eurosports, like cycling. And they have English speech recognition, but it's got European names from Belgium and Norway and Netherlands and Germany and all that are not common in everyday English. And we're able to set an agent to go and say, right, analyze this bicycle race, find all the racers and cyclists, find all the commentators, analyze the route of the race, and get all the street names and things that could possibly appear in speech, and make sure they're in the glossary before we run real-time transcription, which is then putting the subtitle up on the screen. So all of those things are possible. You just got to be smart about it. Okay. Somebody's asking about, because of AI-assisted translation, should they start learning and training and using standard CAT tools? It's more than that. The entire process from front to back is changing. Everything from data ingestion to how you make glossaries and things like that. I suggest you have a look at the blog post when it's up there. You'll find a lot of information about that, and it's got a lot of information about what linguists and organizations can do as well. Where are we? Okay. Do you know any existing multimodal translation platforms to date? Sure, ChatGPT, right out of the box.
Yeah, I mean, there's also for Meta kind of seamless for MT. That's kind of a major effort to make things kind of more kind of speech and text. There's like work from Google, Audio Palm, and so on. So there's various kind of these models in research stages. Clearly, we never really know what OpenAI is doing with ChatGPT, but they definitely demoed that technology, but we don't really know how much it's kind of chained together, or it's like, it's really end-to-end process. So this is a really hot topic where, things are in various stages of development and deployment.
Another question similar to before, but a different angle. Does this mean that CAT tools are made redundant? The answer is no, not by a long shot. In fact, they're just going to get bigger, better, and smarter. They'll be better integrated. They'll talk to more platforms. They will do more things.
Just to give you an example, what you would probably want from a CAT tool is that you can just mark up a word and say like, hey, can you give me a different options?
Right.
This is something that CAT tools can't do, but clearly underlying language model can do. So there's a lot still work to be done to really build really good user interfaces.
Exactly. The user interfaces do need a lot of work. Okay, with upcoming regulations for accessibility coming up across countries, how do you see real-time translation addressing this? I'm not sure which variation or flavor of accessibility regulations you're talking about, but let me address one of them. Generating captions and things for people with disabilities, hard of hearing, hard of sight, things like that. There's a lot of work going on that, including work from our team, so that we can actually generate those captions directly by seeing the background, hearing what's going on, recognizing noises. So recognizing a car going by or a door slamming. or recognizing the tone of somebody's voice so that you can determine that it's angry as opposed to happy, those kinds of things. So there's a lot of regulations in Europe and other countries or regions saying that these kinds of things have to have a certain percentage of content to be accessible. Okay. Personally, these days, I watch every movie with subtitles on when I'm on Netflix or Amazon Prime or whatever, because I just prefer to watch it that way. And I think a lot of people do now. But it's certainly getting very interesting. Okay, so we have another question here. Current LLM performance quickly degrades as you go down the language list, from high resource to low resources. What are your solutions and predictions for this? Very good question.
Yeah, I love this question. This is like one of my favorite research topics right now. And it's actually really astonishing how much kind of the big vendors for kind of these large language models support languages. I mean, if you look at kind of the official description of which languages they support, is usually maybe a handful, maybe a dozen. What was it? Llama 3 had like a list of 12 languages that surprisingly included Thai.
Right.
But it's really, really limited. I think that is fundamentally going to change in the future. It has to change in the future. What currently seems to be happening is that various governments across the world kind of fund large language model development. So there's European efforts to build large language model for European languages. There's a lot going on in India and building languages for all the Indian languages. But I mean, these are kind of fairly targeted solutions. Clearly, there's challenges to build these models because the vast majority of trained data is available in English, and then most of the rest is in like a few dozen languages, and balancing the training data for the low resource languages or high resource languages. So there are a lot of technical problems, but ideally, actually, you want to have a model that it doesn't really matter what language you interact with, you should always get the same responses, and that is currently not the case. So if you ask the same question in different languages, you get different answers, but it shouldn't be like that.
I agree. However, we have seen, and Philip, you might know a bit more about this than I do. We have seen that even when you ask a question in, let's say, Arabic, it can leverage the data that's available in English.
Yeah.
And draw down on that. So it's not just only the Arabic data or only that other language data. You've got actually across the board.
Yeah, I think in a webinar in late last year, we actually had an example where I just asked a language model about myself. Okay, I'm that modest. And if I ask in German, like which universities I went to, it had a perfect list. But if I ask the same question Korean, it was kind of semantically in the right space. All the universities were like German universities, were like all computer science related, but like every single fact was wrong.
Right.
But still, so there's some knowledge transfer across languages, but not all of it. So how do you improve this? As I said, this is a research topic I currently work very actively on.
Right. Okay. Is there work on using translation memories as RAG, as to drive LLM and things around there? Absolutely, we're doing it today. So we're extracting terminology from translation memories, using language model and other things. We're also using them as examples of how to use terminology in context. Okay, and that's proving very, very fruitful. So, there's some very good examples from that. There's you can draw down on lots of memories, but again, you need to make sure that you've got the right content. One of the techniques that we've been using is to create synthetic translation memories or synthetic examples in the target language, so that here's my term, and always have an example of how it's used. Right, and even having a description that let's say it's a term, and it will say this term, like let's say cloud services. It would describe quite literally services hosted by major organizations such as AWS, Google, and Amazon or Microsoft in the cloud to offer compute functionality. So it would give that definition at time of translation, so that the language model knows how to leverage that, and telling it what to do delivers a totally different translation. So there was a paper a little while back where Google did a simple task. They mirrored all the basic steps of a human translator. And they did it in a pretty primitive model, but it showed really promising results. And we do similar things in our platform. I have to say, though, right now it's slow, but still thousands of times faster than a human. But you get much, much better quality when you actually do mirror the steps of a human. And that's a key point. There's no free lunch. So there's going to be a trade-off somewhere. Getting the terminology right. It can generate fantastic terminology for you. You've still got to check it. Make sure it's good. Or you can risk it, and it might be okay, and whenever it gets it wrong, just go in and do a tweak. That's another way, right? It's iterative. Okay, that's all we've got time for today. If you do have any more questions, please don't hesitate to mail me or Philip. You can contact us at sales@omniscien.com and they'll pass the message on to us. As I mentioned previously, there's a whole series of blog posts that will be published on Monday that cover everything we talked about today in great detail. The slides will be shared. A transcription will be shared, analysis of the transcription will be shared, and of course the video will be shared. So thank you again for your time today, and we look forward to talking to you again soon. Thank you. Have a great day. Bye-bye.